I think we should start by saying good morning to everybody. Thank you very, very much for those who have who've turned up this morning to see us all. My name is Darren Taylor. I'm the National Specification and Projects Manager for Tamlite Lighting. I'd like to thank Joss and Ella Summer from CIBSE. Josh, obviously, from the West Midlands region. Thank you very much for giving us the opportunity to present our CPD this morning. I've also got a colleague with me this morning, a gentleman called Stephen Biggs. Stephen is basically the Senior Specification Manager for the West Midlands region, so he's your local man, so to speak. If you've got any questions as the presentation goes on, Joss has told me that he'll interrupt the presentation to ask those questions, or indeed you can save them until the end. It's entirely up to you. But firstly, like I said, thank you very, very much for giving us the opportunity to speak this morning. I'll just share my screen so we can start the presentation proper. Second, just swap the screens around. There you go. So the title of this morning's presentation is the common pitfalls with emergency lighting compliance. And effectively, it's a CIBSE ratified CPD. So obviously, everybody that attends today will get certification of today's attendance. Like I said at the start, if you want to ask questions throughout the presentation, Joss will interrupt me. However, I can't see those questions, so if you want to save them until the end, I'll be more than happy to answer them then for you. So if we get on with the CPD itself. So when we started writing the CPD, we started looking at who actually needs to take notice of it. And hopefully you fall under one of the brackets that you can see here today. So we were looking at lighting designers, architects, lighting consultants, electrical consultants, but also things like facilities managers and electrical contractors. We sometimes overlook these guys and girls when we talk about CPDs, but I think particularly with emergency lighting, they're a real important part of the principle of emergency lighting, particularly when you get to the Regulatory Reform Act and things like this, which we'll be talking about throughout the presentation. So these are the sort of people that we felt needed to take notice of the presentation itself anyway. So this is a holding slide to tell you what the next few slides are going to talk to us about. So we're going to be starting to talk about regulations and standards. So we'll talk about British standards, British standards, European norms, etc. And then we'll start talking about luminaire types, some of which, like a lot of the presentation today, some of it may be familiar to you, but there may be one or two little topics that come up that you don't quite remember or don't quite understand. And hopefully we can go through some of those for you today. We'll also talk about emergency lighting system types as well. What are those system types? How will you use them? As well as talking about emergency lighting design. So if any of you pick up a pen or paper or iPad or whatever to do any designs, then this part is going to be for yourselves. And then we talk about things like standby lighting as well. So they're the main sort of parameters of today's talk. But the one thing I would say before we even start on this presentation, 2 points really. Firstly, whenever you're asked to put a design together on emergency lighting or involve yourself on emergency lighting or anything to do with emergency lighting, your first port of call is to ask your client, or indeed if you're acting on behalf of the client, it may be you that's doing this, is to ask for a formal written risk assessment on the project. Because clearly there are things within emergency lighting in terms of British standard that are requirements for us, so they're legislative, if you like. But then there are other things that are sort of best practice, and again I'll touch upon one or two of those as we go through today's presentation. So they may not actually be part of the British standard, but they would be what we would typically use as best practice in the design. But again, the one thing you will hear me saying throughout is that risk assessments must be carried out on any emergency lighting design that we get ourselves involved with. And effectively, you need to be what's called a responsible person to be able to write such a risk assessment. And if you're all members or affiliates or associate members of CIBSE, and within CIBSE guidelines, it'll tell you what what a responsible person is, what a person with responsibility looks like, and there is actually guidance and guidelines for that. So please have a look at those as well. So we get into the presentation proper now, as it were, and we start saying, well, why do we use emergency lighting? Why do we need emergency lighting within our lives? The first misnomer to sort of clear up really is we don't use emergency lighting for fire. So sometimes you get told, we need to have emergency lighting for when there's a fire. That's not the function of emergency lighting. And sadly, in a fire situation, luminaires will melt, they will fail. So we don't use emergency lighting for fire. We use it for power outage, basically. So that can be planned power outage, or it can be impromptu power outage. But that's effectively why we use emergency lighting. And there are two forms, there are two primary functions within emergency lighting. The first one is probably the most known to us, and that's escape lighting. So I'm actually in my office this morning, but if I was in your office and I'd never been there prior to today, I should basically be able to find my way out of your premises without it causing me any secondary harm or effect, i.e. minimising panic. So we do that with a series of escape legends and ensuring that the corridor, the notional corridor or the escape corridor, is illuminated to certain levels. And we'll talk about those levels a little bit later on. But essentially, that's what escape lighting is there to do. It's by means of allowing me to escape your building effectively. That's the premise of it. And I should be able to do that, as I said, without your assistance, technically. If we've designed it correctly and we've got the signage in the right place, we should be able to do that without your help. The other form of emergency lighting then is standby lighting. And this is commonplace in a couple of sort of areas. So where we want, for example, normal activities can resume. So if, again, remember, we're not talking about fire here, we're talking about power outage. So if, for example, I'm a patron of a hotel and the lights all go out because of a power outage, clearly the first priority from the hotel would be to evacuate us safely out of the building. But in a hotel scenario, they don't want patrons to be stood on the curbside, as it were. They want them back into the hotel. So it may be there's an area, again, via a risk assessment design, that they have as standby lighting. And standby lighting is a lot lower in terms of light levels, but it means that we can actually, if it's safe to do so, we can re-enter the building with just standby lighting until such time as the mains lighting comes back on. Or indeed, as I said, if you want to shut off machinery, if there's any machinery that you feel won't be shut off by the power outage anyway, it'll allow you to safely turn down some of that machinery, before you evacuate the building. So they're the two sort of primary functions of emergency lighting. But again, crucially, making sure that the patrons or indeed the visitors of your buildings are not affected either through physical danger or panic, hence why we use emergency lighting. Then we get on to some of the regulations and some of the numbers, and some of these numbers may be familiar to you, some of them may not. We talk firstly, or the next few slides, we'll be talking about Regulatory Reform Act. This is the Fire Safety Act of 2005. As the name suggests, it came in 2005. Then we're going to talk about BS 5266, BS 60598 2005. This is about manufacturing. This is about who makes a fitting and what they have to abide by. And then one that you perhaps used but didn't know it had a British standard, or didn't know it had this particular British standard, is BS 50171. And again, this is basically central battery systems, UPS type systems, central power supplies. Effectively, is what's governed by 50171. Now, the one regulation number that you might think is missing is BSEN 1838. Any of you that have been involved in emergency lighting design, we use BSEN 1838 for a little while, and it's obviously a European notification number. But BSEN 1838 was actually adopted into BS 5266 anyway. So if you're using BS 5266, it's the latest regulation, and it takes a lot of the information that was in BSEN 1838 and utilises it within that code of practice. And again, we'll get onto what those codes are now. So if we start with the Regulatory Reform Act of 2005, again, some of you may already be familiar with this, but effectively what it means is this requires, so it's not a recommendation, it's a requirement. This requires a responsible person to basically be in charge of the emergency lighting within a building. Now, this is typically for private sector projects, but indeed there are some public sector areas where a Regulatory Reform Act will be implemented as well, universities, colleges and schools, things like this. Now, this basically came about when fire officers no longer visit all buildings. They obviously they're entitled to visit any building at any time to do an emergency lighting check, but prior to 2005, they were checking pretty much all buildings. And so this regulatory format came in and said essentially they would place a personal responsibility within the business or within the location, and they would be deemed as the name suggests, personal responsibility, who enacts and ensures risk assessments are carried out and make sure that emergency routes have got emergency lighting compliance, etc. Now, the person is typically, not always, but typically a director sort of level or even managing director. The reason for that is because it carries an awful lot of responsibility. So the person of responsibility can actually close down a premises or deem it to be non-compliant, therefore issue a non-compliant order and a duration of time to make that project compliant. So clearly that takes somebody who's got some sway and who's got some pull within the business. But effectively what they're looking to do is take reasonable steps to reduce risk from fire. Again, I know we're not talking emergency lighting in fire, but as part of this, they need to also take risks to reduce fire, to ensure that safety is carried out on things like the escape routes. So, if, for example, there's photocopiers in a gangway, or there's trolleys or paper or anything that's blocking an emergency exit point, then they have to be empowered to say, no, that's not good enough. That needs to be moved, and it needs to be moved within a given period of time. So it also involves carrying out fire risk assessment, identifying the escape routes, like I said, and making sure no hazards. Now, the crucial part here as well is if the building has more than 5 employees within it, so quite a small scale really, any more than 5 employees, then the risk assessment needs to be carried out in writing. So it can't just be a goodwill sort of enactment, it needs to be carried out in writing. And then crucially, it needs to be reviewed. The findings need to be reviewed regularly. They say annually, but regularly, and updated where necessary. So if again there's something that's carried out on a risk assessment today on the regulatory format, then if it needs to be put right, it needs to be put right within a given time, because again, effectively they're acting as the fire officers really on these projects now. And again, you'll see a whole host of specific guidance for a range of applications, and they range, as I said, from universities, colleges, right down to small and medium places of work, open air facilities, places with sleeping accommodation. It really is an important body of work, hence why it needs to be given the gravitas of possibly director or above, really. So moving on to the BS 5266, and anybody that's designed emergency lighting, anybody that is designing emergency lighting knows this practice, knows this code off by heart, and probably knows everything that's on this screen. But I'll go through it anyway for some people who don't know it, and maybe give a refresh to some who thought they knew it even. So BS 5266 is basically the Bible, if you like, for emergency lighting design. And if you're going to do emergency lighting design, then I urge you to thoroughly read and digest BS 5266. And if for any reason don't understand it, then speak to lighting partners who can help you with design and help you with some of the details that are on there. We'll get into the numbers on the right hand side in a moment, but if I look at what the range covers, and the range of standards covers, so it's design and installation of emergency lighting. Hence why right at the very start of this presentation I said about electrical contractors. They can't be overlooked, because ultimately they're the people who are installing the project, and to comply with 5266 it needs to be a design and installation partnership really. But it looks at things like emergency escape lighting, it looks at standby lighting, and also looks at duration of emergency lighting. And something, again, we'll talk about duration a little bit later on, but again, there's some interesting views on duration, what people think is the required duration for 5266 and what it actually is. And then we'll talk about things, again, the code of practice talks about installation and wiring and testing as well, really crucial parts. But if we come on to the right-hand side of this slide now, we look at the actual numbers that people may be familiar with, may not be familiar with. And again, some of these were updated when BSEN 1838 came out. So things like the escape route. So we assume when we design that an escape route is 2 meters wide. If it's greater than 2 meters, there are a few that are, but if you think about things like Ministry of Health, so if you think about a hospital, for example, they can be wider than 2 meters. Well, in that case, you treat each of those escape routes as 2 meters wide, effectively. That's how you would treat that corridor. But down the center line of the escape route of the corridor, we need to achieve 1 lux. Now, crucially, when we talk about emergency lighting, there are a few things to really understand that are different to artificial design. So when we use emergency lighting, we only talk minimum light levels. That's the first thing. Normally, when you talk artificial light levels, you talk about average illumination, but in emergency, we talk about minimum. The other crucial part is that your emergency calculations have to be carried out at the ground level. So again, if we're dealing with artificial lighting, we may put a working plane in there of 0.75 as an example. Well, emergency light levels need to be calculated at the ground. And then the third really important criteria is we have to use zero reflectances for emergency lighting. Now, again, in artificial lighting, we may use 70-50-20, 70-50-30 as an example, but in emergency lighting, those reflectances are 0. Now, if you're using a software program such as Relux or Dialux or any of these sorts of things, and you put an emergency plane in, then typically it'll take the light level to the ground, and typically it'll take 0 reflectances. But if for any reason it doesn't, or when you check in, more to the point, you need to make sure those criteria are in place. So again, 0 in terms of working plane, 0 in terms of reflectances, and again, minimum light levels, not average. So 1 lux down the center line of our escape route is the criteria, and then 1 meter either side of that center line, we need to achieve 0.5 lux minimum. Okay. Then in an open area, now an open area is typically an area that's 60 square meters or above, or an area that forms, part of or route to the escape route, etc. Then we need to light that to 0.5 lux, so half a lux effectively. Now, again, with the introduction of 1838, we started talking about high-risk task areas, and they sort of grabbed the imagination, if you like, of designers these days. And it's really, really crucial that we understand what are high-risk task areas and what the light levels are. And there's a bit more of a section on this as we go through the presentation, but I'll deal with it a little bit at this point. So the criteria is we need to achieve 10% of normal illuminance or 15 lux, whichever is greater. So if in a corridor, for example, we're being asked to achieve 150 lux, then 10% of that, well, it wouldn't have to say a corridor, it wouldn't be a high-risk task area in a corridor, but let's just get 150 lux for a moment, then obviously 10% is 15 lux. However, if you're dealing with something like a hospital bay or a first aid treatment area, for example, then a first aid treatment room may be lit to 500 lux. And therefore 10% of the normal illuminance, of course, is 50 lux. But here's the really, really crucial part, and I think this was sort of lost on a lot of us really when we started talking about high-risk task areas. It is only the given area that needs to be illuminated to that high level. So for example, if we talk about a first aid treatment room for a moment, it's only the gurney where the patient is receiving treatment that needs to be lit as a high-risk task area. The area surrounding there, sort of like the seating area or, the cupboard space where you store things, doesn't need to be lit to 10% either. So it's not the entire room, it's just the given task area. Now, one thing that was catching a lot of people out in things like plant rooms and things like this, where you had mains distribution, people were lighting the whole of the room to sort of 15 lux. And again, crucially, it's not that. It's just the given area. It's just the area that's deemed as a high-risk task area. But like I said, there's a little bit more about this later on, so I'll move on from there. But other areas to ensure are things like firefighting and safety equipment need to be taken into consideration as well. So exit signs as well. You'll notice there's been a transition now that all exit signs in the UK, or new exit signs, I should say, in the UK, are green. And the reason for that, really, they're using, for want of a better phrase, a traffic light system that red is danger and green is safe. And so all of the signage now, all of the new signage, and again, we'll talk about signage a bit later, all of the new signage now is green in color and needs to be illuminated to 2 lux as well. Now on a self-illuminated sign, then of course 2 lux is not a problem. Another key consideration on high-risk task areas is things like response times. But again, like I said, we will touch upon those a bit later on. Then we come to manufacturers, lighting manufacturers like ourselves here today. BS 60598 is really a vital standard, and you as designers, as engineers, as contractors, whoever's on today's call, must be holding your manufacturers to account and ensuring that they're manufacturing their luminaires to 60598. Indeed, if a manufacturer is posting what's called a CE mark, the centralized European or code of European number, then 60598 and the CE are comparable effectively. But it doesn't hurt to ask your manufacturer that you're going to put onto a project, are they 60598 compliant? And they should be more than happy to tell you whether they are or whether they're not, and what they're doing about it, etc. The things to look out for and reasons why it's so important that you use a manufacturer that does comply to this legislation. So if I look at very, very simple things and things that we may, take for granted, they need to have instructions provided with inside their luminaires. Now, crucially, those instructions need to be provided in the language of the country they're being used. So we're obviously UK, so we use the English language, and so therefore the instructions need to be in English. Now, of course, the industry as a whole do import products or materials, etc. But crucially, as the user of a product, you need to ensure that those instructions that are given to you are given to you in the language that you need, i.e. in English. And obviously, there's an awful lot of instructions now that have got pictorial guidance, etc. And that's all fine. But it's ensuring A, that they're provided, and B, they're in the language of our choosing, i.e. English. Again, very important. But things like ensuring the body of the product is fire resistant. So you've heard of, or you will have heard of TPA and TPB as an example of a material that's used. TPA being 850 glow wire test, compatible and things like this. So it's ensuring that these are all taken into account as well. But I think there's a couple of really important parts here. Again, that because you're putting your name to a design, you need to ensure your manufacturer is complying with. Photometrics and beam angles, I think, are probably the most important, because essentially, when you're sitting down to design today, again, if you're using Relux or using Dialux or anything of those sorts of ilks, then you're going to need that manufacturer's data, and the manufacturer's data should be based on photometry. We use things like spacing tables an awful lot, or we used to back in the day. I'm an older designer, but still, they would still have been based on data that was given to us via photometry. And beam angles particularly are crucial with emergency lighting, because again, when we get later on, when we're lighting an escape route, knowing how far the spread of light goes is crucially important. So photometrics effectively give you the quantity of luminaires you require for that design. So if you're trying to light an area that's sort of 100 meters by 100 meters, you need to know exactly how many fittings you put into that design. And the only way you know that is with manufacturer's photometric data. And again, speaking as a manufacturer, all manufacturers will be more than happy to supply you with their photometry, with their data. There should be no reason. Most manufacturers publish it anyway. But the one thing they may publish is ballast lumen factors rather than photometry, full photometry on a product. So again, make sure that you understand what data you're being given. Response times, like I said, when we talk about high-risk task areas, response times are really important, and battery life is really important. Again, another sort of misnomer, if you like, about emergency lighting is that under 60598, and I'm careful how I word this because again it's really important, a fitting that provides a 3-hour emergency lighting duration will have a design life. This is not a warranted life, but a design life of 4 years contained within that battery to comply with 60598. Now, the reason it can't be a warranted 4 years although some manufacturers are now stepping up with 2 and 3 year warranties on batteries. But the reason there's a difference between a design warranty and a design life and a warranty life is because you can't control the switching of it. So, for example, when before you hand over a project, it may be that the contractor or the site are using the emergency lighting as lighting on that site, in which case clearly it's not going to last 4 years, those batteries, because they're being drained all of the time while they're in use. It may be they're being switched more frequently than the annual duration test allows. They may be being going through duration tests every month, for example. So these are why they're design lives rather than warranted life, just so that you understand. But these are the some of the crucial facts regarding 60598. But as I said, before I finish on that slide, just speak to your lighting manufacturer that you're partnering up with on a project. They should be more than happy to provide any of this data. So then we move on to BS 50171, which, as I said at the outset of this this sort of section, is something you may use regularly, but you may not have known that it had a British standard or indeed what the number was. So 50171 is the central power supply, central battery, central UPS, uninterrupted power supplies. This is what 50171 is. And essentially, it's again, it's governing power supply systems for independent energy supply to electrical safety equipment. It's essentially what it's doing. Now, things like again, Ministry of Health. So we talk about hospitals for a moment, Ministry of Defence. These sorts of places and some larger offices will use central power and central battery instead of standalone sort of integral emergencies. And the reason for that, if you think about a hospital just for a moment, and sorry to get a little bit garish here, but if you're just going into an operating theatre as an example, and the operating theatre is lit to 1,000 lux, for example, you've just opened Johnny or Janie up on the gurney and the power goes out. Clearly, you can't then either continue with the operation if it's life-threatening, or indeed conclude the operation in sort of 1 lux lighting. You've got to still have the 1,000 lux. Well, clearly, you're not going to get that light level with standalone or integral battery products. You're going to have to use a power supply sufficient enough to be able to control those luminaires to that light level. So again, I said earlier, a luminaire will have a ballast lumen factor typically of about 10%. Well, 10% of 2,000 lumen, 3,000 lumen fitting, again, is only 200 lumens. So knowing that you're going to have to try and get to, say, 1,000 lux as an example, means you'd have hundreds of these things on the ceiling. So it's not the way to do it. So that's why central battery and central power supplies are used more heavily in things like in things like hospital units, etc. The standard cover systems permanently connected to AC supply voltage, not exceeding 1,000 volts, and that use batteries and alternative power supply. So that's essentially the full guidance on what 50171 is. But again, the central power supply is intended to energize emergency escape lighting in case of failure, in case of failure of the normal supply. But again, suitable for energizing other safety equipment. Again, perhaps a little bit old-fashioned now, but certainly, back in the day, things like call systems would be utilized on central power. But smoke extraction equipment and carbon monoxide systems can also be regulated via central power and central batteries. And again, they would come under 50171 as well. So the next few slides now, we're going to start to talk about luminaire and system types. And again, some of these will be familiar to you. So we talk about maintained, non-maintained, sustained might be an interesting one to some of the younger viewers here today. We'll talk about duration as well, and then go through some of the system types as well as looking at viewing distances, which I think are really crucial for us when we talk about emergency design. So if we look at luminaire categories, so firstly, we're looking at a non-maintained light source, a maintained light source, and like I said, a sustained light source. So looking at a non-maintained, this is the most basic, most simple product. This is a light fitting, typically self a luminaire with the battery enclosed, and it's a light fitting that will never be on unless there's an emergency power outage. So, you know, some of you will see and remember bulkheads up on the ceiling that again, never illuminated. Only time they're illuminated is when you do a flash test, a duration test, or you have a power outage. Conversely, a maintained light fitting, again, is a light fitting that operates with main power supply. So it will be illuminated all of the time. And then when you have a power outage, then the battery backup part of it will kick in. But it also means that it's a switchable unit as well. That's another crucial part. Sustained, again, I said earlier, some younger sort of participants here may not remember what a sustained product was, but effectively, if you think about it in a fluorescent world for a moment, you would have one lamp that would be on emergency mode only, and one lamp that would be on mains operation. Now, if we talk about that in terms of the LED world for a moment, I'll go back a slide, and the fitting that's the right-hand side of the exit box that you see there could technically be described as a sustained product, because there's an emergency lighting pod that plugs into the end of a luminaire, therefore allowing it to be, you know, two sources. One source is light and one source is emergency, and they're switched independently, and that's effectively what we know by by the terms of sustained. And again, we use maintained luminaires are required in following establishments: non-residential public buildings, places that provide sleeping accommodation, and dark rooms as well. We use maintained. Now, again, very, very quickly on places of sleeping accommodation, the one thing, again, it's not perhaps part of a CPD, but it's something that happens within the industry that we get asked about regularly, is that the neon indicator on an emergency fitting can be pretty bright these days. They're an LED light source, and therefore they can be pretty bright. Again, please feel free to speak to your lighting manufacturers about putting inline resistors in to actually tone those down slightly. Again, these are, I said earlier, there are things that are best practice and things that are regulatory. That's a best practice one. So we talk about duration, and I said earlier, some of you may be surprised by what the duration requirements are for emergency lighting. And BS 5266 stipulates that emergency lighting must have a duration of no less than 1 hour. So to comply with BS 5266, you're allowed to use a luminaire or a light source that gives you 1 hour duration. If you've done your full risk assessment, you won't reoccupy the building as an example, but you feel that you can clear the building out in that time, then you're allowed to use a 1 hour light source. Now, to my knowledge, there's only one lighting manufacturer that have on the market a 1 hour duration luminaire. So they're very, very difficult to come by, if you want to call it that. And typically now the industry standard is 3 hours, but it's not. Again, it's generally accepted that 3 hours is the right way to go. But I'm just saying, if you wanted to design to 5266 and you only wanted to use a 1 hour power supply, you can do so. You won't be sort of breaking the law, again, as long as you've done your full risk assessment. But 3 hours, the reason we use 3 hours really as an industry, and we've grown accustomed to it, again, is to allow people to reoccupy the building if it's safe to do so. That's where 3 hours started to become more of the norm, so to speak. I'm just conscious of time, so I should speed up a little bit. Then we're going to talk now very briefly about system types, and we talk about self-contained, we talk about slave units, and we talk about mains conversions. Self-contained, really, really straightforward. This is a light source that, so you've got a light source, a battery, and a control unit that provide a housing within the luminaire housing, of the luminaire, or within 1 meter of. So what that means is a lot of fittings now come with the emergency gear on umbilical cords, and they have the emergency batteries, etc. All of the components need to be mounted within 1 meter of the light source. But products that are becoming much more familiar again as with the industry, fittings such as the fitting below the exit box there that you can see, that would be a self-contained light source, because effectively it's got a battery backup and it's got the luminaire installed within it, and that particular product is becoming more popular because of the spacings that we can get on those products now. Perhaps not the most politically correct terminology, but we still use it as an industry as a slave product. And all we mean by that is that, again, a product that's got a central battery system. So I'll go back to 50171 for a moment. So we've got a central power supply. all the fittings off that product will then be deemed a slave luminaire, i.e. it's a dummy luminaire. It doesn't have any other sort of means of use other than off the central power supply, central battery system. And then we've got mains conversions. These were very popular during the 90s and noughties, as it were. But again, they've been overtaken now more by the standalone spots. But any luminaire that's converted with so you have a light source, and then you'll have the batteries to back up some of that light source. And again, I said earlier about ballast lumen factors. Really, really crucial when you're looking at mains conversion, again, because it's only typically 10%, not always, but typically 10% of the output of the product is working on emergency mode.
Darren, sorry to interrupt, but there's just a question regarding slave luminaires and whether they need to comply with BS 60598.
They would, because again, it would still have you would still need the photometric data, you would still need the instruction data, so they would still be 60598 compliant. Yes.
Lovely, thank you.
No problem. It's good to know this works anyway, Joss. I'm glad you answered, because I thought I was talking to myself for half an hour. So move on anyway. So again, now we look at things like viewing distances, because again, really, really important that we get our viewing distances right when we're designing. So there's actually a mathematical sum to tell us how what the spacings need to be. So if we look at the first one for a moment, this is an internally illuminated product. So for example, this is an exit sign that's got a light source already within the body of the structure. That's what's called an internally illuminated sign. And then we're allowed a viewing distance of D, which is the distance, times H, which is the height, and the height is the height of the legend, i.e. typically, again, 190 mil or 200 mil high. So we have the 200 times the height of the legend gives us the maximum viewing distance from that bulkhead, from that emergency bulkhead. Now, if you assume that it's a 200 mil high signage, then 200 times 200 is obviously 40 meters. So the maximum viewing distance on that exit sign will be 40 meters. Conversely, I go to many buildings where they're using sort of 50 mil high exit signage because they look a little bit prettier than some of the 200 mil cumbersome ones. But clearly that means then that the viewing distance is a quarter of that 40 meters, so only 10 meters viewing distance. Again, conversely, if you shop at certain supermarkets, you'll see that they have much bigger exit signs, so they can be as high as sort of 1,000 mil or 1,200 mil high. And what they've done there as part of their risk assessment is they've deemed that at any point in that vicinity of their supermarket, 200 times the height of that illuminated sign means that you'll be able to see that one exit sign or maybe two exit signs from anywhere within the floor of their space. So they've again, part of their risk assessment have decided go for a much bigger sign. And therefore, obviously, in some cases, quadruple and the viewing distance. Crucially, though, an externally illuminated sign, and this is really crucial. So if you've got a sticker, for example, and we'll talk a moment about what the stickers and some of the parameters around those now, then the sticker needs to be illuminated or can only have a viewing distance of half the length, so 100 times the height of the legend. Okay, so an internally illuminated sign is your best way of expanding or getting the maximum viewing distance. But if you're using an externally illuminated sign, then it's half the viewing distance. Now, really crucial while we're talking about stickers, because one fashion product, if you like, over the last sort of 10 or 15 years has been photoluminescent signs. And crucially, an LED light source, if you're using LED as your lighting parameters for most of your buildings now, and obviously with the with fluorescent tubes going to be outlawed very shortly, then if you're not already, you will be using LED as part of your luminaire schedules. Then LEDs neither produce UV or infrared. They don't produce either of those parameters, and a photoluminescent sign needs either infrared or ultraviolet UV in order to charge itself. Now, clearly, if you've got windows in an establishment, you're going to get that from natural daylight. But if you're relying on a luminaire, so if you're talking again, some of these corridors in hospitals or Ministry of Defence, etc., are vast corridors with no outside lumen, no outside source of lighting. They've got these stickers. Universities are another place where they'll have these stickers around. Well, clearly they were designed when fluorescent was being used as their lighting source. LED doesn't produce UV or IR, so therefore it won't charge photoluminescent signs. So if you're using them, or you have used them on a design, it may be time to think of a different way of using them. Now, clearly you can still use them as long as you've got a luminaire directly apportioned to it. But sometimes you'll see these spacings on these corridors, they're 5, 10, 20, 15 meters apart, and the photoluminescent sign will be in between all of those. So getting only getting light from the LED light source that's not emergency, so therefore it won't work. Okay, while we're talking about signage, let's talk about signs that are allowed and how we use signs today. You might be surprised to know there's only one sign currently on this particular slide that you can't use any longer, and that's the exit sign on the bottom left-hand corner. So the rule about, sorry, just so you've got guidance as well, they were sort of outlawed, for want of a better phrase, in this 24th December 1998. So they've been out of fashion for an awful long time, but there are still some in existence. Now the rule with signage is you cannot mix signage on a project. I'm sure a few of you are laughing because there's not a project I go to where there's not mixed signage. But the regulations state if you're carrying out a major refurbishment of a project that you don't mix any signage on that site. The new signs that we use as an industry now are the ISO 7010 signs that you'll see in the top left-hand corner. Any light fitting you get from any lighting manufacturer will come with an ISO 7010 sign, attached, as it were. So what you're allowed to do, so for example, if you're going to put one exit box up, there's an ISO 7010 sign, but you have all of these signs in the bottom, say the middle one for a moment, the middle sign on the bottom row, then what you would do, you wouldn't mix those signs, and you clearly wouldn't backdate all of the other signs to ISO 7010. All you would do is get another legend that complies with the exit sign that you can see in front of you. So the idea is you're not allowed to mix any, but if you are doing a new or major refurb, then they all need to go up to 7010. Now, the reason for this and the sign that I've mentioned there, the second one down on the in the middle at the bottom row, will probably be the next sign to be sort of discontinued. The reason being is that we're a society now where the English language is not the primary language of all of our all of our countrymen and women, as it were, and so therefore we are looking to do away with wordage on signage and looking for pictograms instead. So there's a real a common sense idea as to why these signs are changing and why we're getting rid of wordage on signs. Now, the other sort of crucial part when we talk about signage that people seem to get wrong or forgotten or never really learned. Previously, again, up until the introduction of BSEN 1838 and now the updated 5266, in terms of signage, in terms of direction of exit or arrow, should we call it, then unless you're telling me my means of escape is down an elevated path or indeed down a set of stairs, then it's always, I repeat, always arrow up. Okay. Now, the thinking behind this, if any of you remember your driving test, or some youngsters who are doing their driving test currently will know that when you're sitting with a driving instructor, they tell you to proceed in a forward direction until you're told otherwise. And it's the same view, really, it's the same viewpoint in terms of emergency signage. Unless you're told otherwise, your means of escape should be ahead of you. Now, you can still use left arrows, right arrows, 45-degree arrows. None of them are outlawed, so to speak. But in terms of the up arrow and the down arrow, the misnomer behind it, we again, those of us old enough to remember designing many years ago, it was always a down arrow at final exit. It's now an up arrow. The only time you use a down arrow on your designs now is if you are telling me my means of escape is down a flight of stairs or a ramp of some kind. Okay. So hopefully we've cleared that one up today. Again, moving quickly on because this one's a holding slide. This is basically telling us some of the system designs and some of the considerations that we need to use when we're doing system designs. And the next slide I bring up is probably very, you'll have seen this in multiple presentations, but I'll talk you through it stage by stage in a moment. And this is how we should design essentially a capillary, an artery, or an escape route. So that's the slide. And again, I'm sure many of you have seen this one in the past many times. So essentially, we treat an escape route, in this case, a flight of stairs, then corridors with a ramp or with a step, etc. We treat it, like I said, right at the very beginning, with 1 lux down the center line and 0.5 lux, 0.5 meters either side of that center line. Okay. So if we start at step 1, which is the entitled stairs. Now, as a designer, our job is to illuminate every single tread of that flight of stairs to 1 lux down the center line and half a lux, half a meter either side. Now, we hear sometimes where people say, well, we'll just put one up there and you know, it'll be fine. Well, it's not fine. It needs to, every single tread of stairs needs to be illuminated to that 1 lux minimum and 0.5 lux, half a meter either side. But let's assume we've done that. So as I've come down that flight of stairs now, I'm going to turn right. Within half a meter of that turn, you need to warn me that there's a change of direction effectively. Okay. And then again, as we walk our way back down this this corridor, we have another change of level. Now that change of level in this case is a step. It can quite easily be a ramp, you know, disabled access ramp. But again, within half a meter of that change, directly on that change of level, forgive me, you have to illuminate to 1 lux down the center line and 0.5 lux, 0.5 meters either side. Then we have another change of direction before we finally hit our final escape. So again, this is how we treat every single means of exit on an emergency design. So whether that's 5 flights of stairs, 1 flight of stairs, it doesn't matter. This is how we treat every single one of them that's been deemed as an escape route. A couple of other really important numbers, and I'll come to the ratio in a moment because that takes a little bit more explaining. But the response time on the emergency lighting, because it's an escape route, it needs to be 5 seconds to reach 50% of the output and 60 seconds to reach 100% of the output. So if you're using, for example, an old tungsten twin spot luminaire as an example, it may be that 60 seconds to reach 100% is asking a bit much of it. If you're using a fluorescent high frequency product or an LED product, then none of those numbers are a challenge for you. You know, 5 seconds to reach 50% is not a problem in any way, shape or form, and 60 seconds to reach 100% isn't a problem either. But if you are using old tungsten type twin spots, it may be when they're doing their checks, again, go back to the Regulatory Reform Act for a moment, when they're doing their tests, if the response times are over those numbers, then they need to be updated. The other crucial part is the color rendering needs to be over 40 RA as well. Now there's a sort of change to correlated color temperature appetite, if you want to call it that, within designs these days. We're using more and more warmer colors, 3000 CCT, 3000 Kelvin as an example. When it comes to emergency lighting, they all have to be over 40 in terms of RA. Now then, let's take this minimum maximum illumination ratio for a moment. It needs to be 40 to 1. What do we mean by that? Well, effectively, when you're doing an artificial design, you'll use a uniformity factor, i.e. how uniform that light level is. And in terms of emergency lighting, it's worded slightly differently, but it means the same sort of thing. And then again, if you're using a software program such as Relux or Dilux, you'll have a min and max illumination number, and 40 to 1 is the requirement for an escape route. So what that means is we can't, for example, I know we don't, but just hear me out for a moment. If you've got a great big floodlight on the wall here where it says change of direction as an example, you can't put one big floodlight and hope to get 1 lux all the way up that corridor. What it's basically trying to make sure we do is that we use multiple emergency lighting throughout that corridor. So 40 to 1, you can't go above 40 lux in terms of that corridor is essentially what we mean by that. And it's deemed again on software programs as E-min and E-max. That's basically the numbers that you'll see, or it might have a D for design as well. Sometimes diversity uniformity is what it's also known as well. So that's the important things on those. Now, if you keep those response times in mind a moment, the next slide I go on to is open area, and you'll see that exactly the same numbers effectively. So again, 5 seconds to reach 50%, 60 seconds to reach 100%. The E-min, E-max number is still the same, 40 to 1. The light level has changed. Okay, so we're no longer talking about 1 lux minimum. We're now talking about half a lux in the core area. Now, again, open areas are defined as spaces that are over 60 square meters, including offices, shops, and covered car parks. Toilets that are over 8 square meters as well. Again, lots of toilets get calculated every day, and people don't realize that if it's over 8 square meters, you have to put emergency lighting in there. Another quick thing while we're talking about toilets for a moment. If you're using floor to ceiling doors and privacy walls, then every single cubicle needs to be illuminated. Okay, if you just got privacy doors that are sort of halfway and you're using spilled light from the rest of the room, then clearly, as long as you calculate it correctly, you don't have to put an emergency light over every cubicle. But if you are using floor to ceiling privacy, then you have to illuminate every single every single cubicle. Another quick thing while we talk about toilets and we talk about lighting and guidance over sort of regulation, you can use other forms of lighting in terms of emergency lighting. So, for example, if you wanted to use a BS 5266 torch, for example, which is a constantly powered torch, only utilised in emergency mode, then as provided, again, you've done your risk assessment, you've carried that out, then you can use that. But the one thing you can't use, and this is perhaps why I talk about it in toilets, God knows why we do take these to toilets, but lots of people use their mobile phones. But unfortunately, you can't, I say unfortunately, you cannot use phones as part of your risk assessment, or indeed as part of your luminaire levels, because again, you don't know how much charge is left on that phone, and therefore you've got to be allowed, or you've got to have the 1 hour minimum duration. But again, things like torches can be utilised if required.
Darren?
Yes.
Just on risk assessments.
Yes.
There's a question asking whether the risk assessment should include for smoke cloaks accidentally being activated and dispersed either during the day or evening in relation to the escape route, as an example being in a retail store trading.
I don't know the answer, Josh, but if you send me the question, I'll find you the answer out. I don't know it, I'm sorry.
Lovely, will do. Thank you.
No problem, thank you. Talking about high-risk task areas in a little bit more detail. Again, I'm conscious of time, but a little bit more detail. The first thing you'll notice before anything else, I guess, if I go back a slide, look at the response times, how they change. So they go from 5 seconds to reach 50%, 60 seconds to reach 100%. We're now talking about 0.5 seconds, so half a second to reach 100%. Okay, no ifs, no buts, no maybes, half a second to reach 100%. Why is it such a strict criteria? Look at the name. It's called a high-risk task area for a reason. You've deemed it high risk, therefore the requirements state that response time is almost immediate to get to 100%. Now, again, if you're using things like T5 luminaires with a quality high frequency circuits, or you're using LED, again, 0.5 seconds to reach 100% is not a problem. But again, I go back to my analogy previously. If tungsten was a problem to get there in 60 seconds, you can be damn sure getting there in 0.5 seconds is probably going to be an impossibility for some products. So therefore, again, as part of the risk assessment, as part of the Regulatory Reform Act, you must, if it's deemed a high-risk task areas, response times need to be met. Then we talk about some of the other numbers that are on the screen here. We've already touched upon the 10% of normal illuminance or 15 lux, whichever is greater. But the other thing you now see is the ratio needs to be 10 to 1. Again, think about it. We're talking about a task area now, a smaller area maybe, and therefore we don't want to just blitz the whole area with illumination. We only want that given task area. So hence the ratio, the minimum maximum illumination now is down to 10:1. Color rendering again is RA of 40 or above. Now areas that are, just give you some examples. I've already touched upon electrical plant rooms, first aid rooms as an example, but there are other areas. There are things like moving machinery, areas with moving vehicles, anywhere they're containing flammable materials, control rooms. These can all be deemed high-risk task areas. But essentially, again, I'm sorry to keep using it, but it depends what's discussed on the risk assessment as to what is a high-risk task area. There are lots of parameters set out in the SLL guide and now in the new code for lighting as well. But ultimately, you as the designer determine what is the high-risk task area. Things like, there are very, very obvious ones, hot plates, for example, in a kitchen area. If you're lighting a kitchen and you know the power goes out on an electric hot point, then it's still going to be hot while there's no illumination. Therefore, it needs to be lit to a higher light level. But there are also sort of anomalies with things like fixed coffee machines. Some people will look at that as a high-risk task areas, others won't. Again, it comes down to you with risk assessment. That's why I say some things are regulatory and some things are best practice. Personally, as a designer, I would look at each and every one of those given its merits and find out who's using those pieces of machinery or those hot plates, etc., before I decide whether or not it's a high-risk task area. The probability is I would probably be a little bit over the top in terms of making sure that I cover all aspects in high-risk task area. But there are additional areas to consider again on high risk and system design. Indeed, lift cars, escalators, moving platforms, all of these things. You know, anywhere really where it's moving. Okay, I know you're going to have a power outage, but it may be that you still want to illuminate it to get people off those moving platforms safely. Another area, nothing to do with high risk now, just in terms of lighting in general for emergency lighting. Another area for consideration is places of entertainment, and anybody that's done designs on places of entertainment, now they're fairly difficult to actually achieve some of the numbers, because we now need to illuminate to 0.1 lux in the seated areas and then 1 lux along the centre aisles of the gangways. So if you think about a cinema for a moment, all of the patrons will be in sort of seating areas in sort of amphitheatre style. Well, the person in the centre of that seating area may be 20 meters, 10 meters away from the gangway itself, from the aisle of escape itself. Therefore, light, and if they've got movement restrictions or they're short of sight, etc., then clearly ensuring that they're illuminated to safely get themselves onto the gangway is crucial. So 0.1 lux in the seated area is now a requirement, and then 1 lux again throughout the gangway. So then we treat the gangways as notional corridors or escape routes. So we go back to the 1 lux minimum, 0.5 lux, 0.5 meters either side, etc. Very, very straightforward. But it's light in the seated area now that's really, really crucial. My last but one slide, you'd be pleased to know, is on muster areas. Unfortunately, muster areas take a little while to talk about, but let's go through it for a moment. So assuming now that you've allowed me to escape the building safely, your primary role of ensuring no risk to myself is not over yet. You now need to guide me safely to a muster area. Now, in some cases, I use the word very carefully, in some cases, that muster area may be 100 meters away from the building. If that's what's been deemed as the requirement and part of the risk assessment or insurance policies, etc., particularly things like higher education, university buildings, their muster areas will be, 50, 80, 100 meters away from the building because they want their patrons well away from the building itself. Well, the whole of my journey to that muster area needs to be treated as a corridor, as an emergency lighting corridor. Therefore, you have to light the whole of that area to 1 lux down the centre line. Clearly, that's a really, really difficult task, and there's only certain fittings that will allow you to do it. You can find bollards with emergency battery backups inside, so you can use those. You can go back to what I said earlier on and use a torch if you deemed it as part of your risk assessment. You can use that. But ultimately, if it's 100 meters away, by decision, You knew it was 100 meters away, therefore you have to light that path safely in order for me to get to the muster area. Okay. So again, really, when you're building muster areas, when you're designing muster areas, just have in mind how far away you're going as to how far away you're going to have to illuminate. Now, I have got one friend in this scenario as well, just so you know. If, and I underline the word if the street lighting is on a different circuit, and you can adjudge that via your electricity suppliers, then you can utilize the road lights in an area to as part of your design. You can't use moonlight as part of your design, just so you know. And clearly, if you're working in areas of dark sky and this sort of thing, then it may be that you're 20, 30 meters away from the nearest lamppost, in which case, again, it might not be as much of a friend as you think, but you can use it as part of your calculations anyway.
Darren, a couple of questions,
Yes,
if I may.
of course.
One of them goes back to risk assessments of high risk areas.
Yes.
The question is, it's done by risk assessment, but is there any further guidance on that?
Yes. Sorry, just I'm gonna slurp a drink. So again, if you look in the SLL guide or look in 5266, it'll give you guidance of where you should be looking at, not ultimately every area, but it'll give you guidance on what areas come under high risk task areas. They're pretty straightforward, and once you've done a couple of designs, you get to know them. Again, if you're doing kitchens, this is just a flippant answer, but please take it for what it is. If you're doing commercial kitchens, it's pretty much everywhere. You're looking at again, hot plates, soup tureens, fixed coffee machines, cookers, gas stoves, these sorts of things. If you're talking about things like plant rooms, like I said, it's only the given area. It's only the distribution box on the wall, for example. Certain things that are not high risk that you might think are high risk, we say that data is the new oil in the world these days. Well, data rooms are not classed as high risk task areas. But another thing that is deemed a high risk task area needs to be illuminated, that's possibly a little bit strange, is an analog telephone. Because again, if you think about the power is going to be out, then having a analog telephone in order to be able to call for help needs to be distinguished as a high risk task area. Things like first aid rooms, obviously, but first aid boxes, eye wash boxes, all of these things, but they're all contained. There's guidance, like I said, in 5266 or the SLL guide.
Excellent, lovely, thank you very much.
Or finally, sorry, and I'm not, again, this is not a pitch for obvious reasons because the CPD, speak to your lighting manufacturers. They're dealing with this day in, day out, and whoever your manufacturer is, they'll be happy to design knowing, once they talk to you about these areas. Sorry, carry on.
That's all right. They're off seeking that information as we speak, so thank you for that. Another couple of questions, if I may. So there's a question from a person who's got some software that records and creates schedules and lighting data and automates the results. But the question is, does it need to be certified or accredited to generate test results and record the luminaire data for future testing?
That's a really, really good question, and the answer is yes. You're going to use, again, I won't name manufacturers because this is a CPD, but if you use it in certain manufacturers, some of them will have they'll charge you a nominal amount or an amount each year to study and maintain that data. Other manufacturers will just give it to you in terms of software packages. It'll send you SMS or MMS updates, and as long as you store and log those details, then you're compliant within. So, for example, because again, with emergency lighting, one thing I should have said a little bit earlier, and I forgot. Forgive me, I was talking over myself. When you discharge an emergency luminaire, it's 24 hours before you can use that luminaire again. Okay, so if you're doing a test, hypothetically, I know you wouldn't, but say you started that test at 9 o'clock this morning, it's going to be 3-hour duration test. So again, 12 o'clock is when the duration will be finished. 9, 10, 11, 12. Yeah, sorry, I had to do the math. And then basically it's 12 o'clock tomorrow before that product becomes usable again. Okay, this is why sometimes you'll see 2 emergency light fittings in a corridor when it's only sort of 9 or 10 meters long in between fire barriers in a corridor. The reason you'll see 2 is best practice, and the reason being, if one fitting, like I said, discharges, it's 24 hours before it can get used again, or If it fails and breaks down, you have a backup fitting. Now, going back to your recording, if you do typically, if you're doing addressable emergency luminaires, then the fitting won't do its test today, for example. It might do it on Christmas Day, or it'll do it on Easter or Good Friday, or these sorts of things, and it'll randomly do flash tests throughout the night, and it'll scatter where it does full duration tests. Now, like I said, every day when you come into your building, you'll have an update, an MMS or an SMS notification if there's a problem with a product. Or indeed if this test went well. If there's a problem with the product, then clearly you have a duty of care to replace or upgrade that, whether it's a battery, a light source, or these sorts of things. But as long as you keep that data in terms of paper format and digital format, then you're covered in terms of compliance. Sorry, I whittled on a bit, but I hope that gave you the answer.
Lovely, thank you for that. And then the other question is regarding street lamps. Is this assuming the supply is taken from elsewhere on the LV network and not from the building being escaped from? Sorry,
I thought I said that. It's as long as it's on a separate circuit, then yes. If it's on your circuit, forget about it, because it'll switch off at the same time as your building.
Separately metered?
Separately metered, yes.
Okay, lovely, thank you.
No problem. Last slide anyway, I'm sure some of you will be pleased to note, and this is probably a more of a begging letter for as a manufacturer who designs every day, I guess, and it's things like firefighting equipment. I don't know how many of you on there get involved in design, but when was the last time you saw a set of drawings come out with firefighting equipment on? Next to never, I would suggest. Now, sometimes that's because it's not known until soft landing of a project, if it's a movable product, etc. But if it's a fixed to wall product, there should be a knowledge of where the firefighting equipment is going to be placed beforehand. The reason it's really, really important, again, it's a high-risk task area, and as an industry, we have to light that firefighting equipment to 15 lux. So we have to get 15 lux on the vertical as well, incidentally. Again, when you're doing things like mains distribution boards, I said earlier, the 15 lux is on the vertical, it's not on the horizontal. So knowing where they are on a project is really sacrosanct. We should always know where they are, but sadly we don't. But there are other things such as core points manual release equipment. They require 5 lux in terms of light levels. Again, in terms of knowing where they're placed on a project is better for all of us, really. So if you know, and you can tell your whoever's designing, whether that's a manufacturer or consultant, where they're going to be placed, I'm sure it will help us all. And on that note, I say thank you very much, and I hope I've been able to give you some insight into emergency lighting. And I'll just stop sharing my screen and come back to real life and say thank you.
Excellent.
Any other questions at all, Josh?
That's really useful. Thank you for that, Darren.
My pleasure. Josh was also, sorry, apologies, you're going to say it yourself anyway. You're going to do a webinar feedback, and obviously always welcome. Thank you.
Yeah, so if people do have any other questions or any feedback or any knowledge deficits or hungers that they've got, then please use the chat function to either drop those in, or alternatively, if you visit www.menti.com and use the code 51358823 and then pop your questions in there, then we will endeavour to get them answered. But whilst everybody's scrabbling around trying to find another browser window or their mobile phones to go on to Menti or wherever, there have been some more engagement and interaction in the chat. So there's a question there, which is there a document that tells you the desired illuminance over safety equipment and things, for example?
Yes, PS5266 and the SLL guide, both of them will. Just incidentally, Josh, by the way, apologies. Regarding the question I couldn't answer, I don't know the answer, so I will never blag it and say I think I know it. Just send me that question and we'll get you the answer, but I don't know that one. But yeah, in terms of where those light levels are published, PS5266 and/or, well, in some cases, the SLL guide will also give you numbers as well. Or again, as I said, speak to a manufacturer. They're dealing with it every day of the week, so they know them.
And there have been a couple of requests for copies of the presentation slides, one of whom's given contact details, which is great. Thank you very much for that. With regards to contact details, we're mindful of GDPR permissions and what have you, so we'll be working with Darren and Tamlite to get information circulating. But a recording of today's presentation will be available on YouTube shortly. So if anybody wants to catch up or wants to share this information with colleagues, then it'll be available on YouTube. I don't think there are any other questions at the moment. There's a bit of feedback coming through on Menti. So for now, I think we'll draw things to a close. I'm sure that everybody on the call would like to pass on their appreciation to you, Darren, and to your colleagues at Tamlite, and thank you very much for today's CPD session. There is another session later on this afternoon. We've also got a number of other events detailed on our Eventbrite page, some of which are with Darren and his colleagues in the future. I can't remember what the next one's on, Darren.
You got me stumped. I think it was on, forgive me, I think it was on optics.
Excellent. And yeah, if anybody's after anything else, then please don't hesitate to get in touch via whatever means. But a virtual thank you from everybody in attendance to you, Darren, and colleagues at Tamlite.
And thank you, Joss, and thank you for everybody for paying attention. And like I said, hopefully somebody got one or two little bits out of it, and that's all we can ever ask for. Thank you very, very much for your time. We're really grateful.
Excellent. I wish you all a good rest of the day, afternoon and evening, and look forward to seeing you at the next event.
Perfect. Thank you very much. Cheers, Joss.
Thanks,
guys. All the best. Bye-bye.